In this video, we'll solve the following three logarithmic equations. Let's start from problem A. Log with base of 2 of x plus 3 equals 5. All right, so the first step is to turn this log into its exponential form, since we have the form of a log equals to a number, right? So the exponential form of this logarithmic equation is, first let's find the base. The base is 2. Then the exponent. The exponent is the answer of the log, right, which is 5. So 2 to the power of 5 equals what's left, the argument, x plus 3. We're pretty much done. 2 to the 5 is 2 times 2 times 2 times 2 times 2. Right? It's 32. 32 equals x plus 3. So x is 32 minus 3, which is 29. And that is the answer to this equation. When we solve a log equation, we want to always check if the argument is positive. So 29, if you plug it back into the argument, which is x plus 3, 29 plus 3 is 32. It's a positive number, right? So that means this is a solution, and sometimes it's not positive. So then that answer is not a solution. Now let's look at problem B here. Problem B here has a log plus another log equals to a number. We have to write the left side as 1 log first. So you have 1 log equals to a number, then we'll turn it into its exponential form. Right, so first we'll write these 2 logs into 1 log. Since they both have the base of 4, we can use the product rule, log with base 4 of, multiply the 2 arguments to become the new argument of that single log. Okay, equals 2. Okay, now we have a single log equals to a number. We can write this equation into its exponential form. Show form, which is the base 4, exponent 2 equals the argument, what's left, right? It's x minus 6 times x. Okay, so first of all, on the left side, 4 squared is 16 equals, distribute, you have x squared minus 6x. We have a quadratic equation here. We know to solve a quadratic equation, you want to move everything to one side and leave the other side 0. So I'm going to subtract 16 on both sides. So I have 0 equals x squared minus 6x minus 16. And first I will try to solve it by factoring. So to factor the right side, if it is factorable, it will be in this form. We want to find 2 numbers. They multiply to be negative 16, and they add up to be negative 6. So what makes 16? 2 times 8, right? So I think I found the 2 numbers, negative 8 and positive 2, which they multiply to be negative 16 and add up to be negative 8. Okay. So here I can write x minus 8 equals 0, or x plus 2 equals 0. So the solutions, either x is equal to 8 or x is equal to negative 2. But you have to check your solutions. Remember, you want to make sure your x will make each argument, we have 2 arguments here, positive. All right, so if you check 8, if you plug in 8 into the first argument, 8 minus 6, that's a positive 2. It's making the first argument positive. And 8, you plug it into the second argument. Well, 8 is positive itself. So 8 is a solution. How about negative 2? Well, if you plug in negative 2 into the argument, which is x minus 6, you have negative 2 minus 6, which is negative 8. It's making the argument negative. That makes this not a solution because this is making the argument part negative. So the log is undefined, right? So we only have one solution here, which is x is equal to 8. Now let's look at problem C. Okay, so in this problem, on the left side, we have 2 logs, and it's subtraction in the middle. Again, we're going to write the left side as 1 log first, using the quotient rule, because it's subtraction. So you will have log, since both of the logs have base 3, so it's log with base 3 as our single log. And the argument part is the quotient of the 2 arguments equals 1. Okay, to solve this equation, we have to turn this log equation into its exponential form, where the base is 3, exponent is 1, equals the argument. Okay, so 3 to the 1 is just 3. All right, how do we solve this equation? Well, you can think of 3 as 3 over 1, and there is a property we can cross multiply. That means 3 times x plus 5 is equal to 1 times x, cross multiply. So on the left side, you have 3x equals 15, distributive property. On the right side, you have x. Then it's an easy problem to solve. You could subtract 3x on both sides. So 15 equals negative 2x. Then divide both sides by negative 2. So x equals negative 15 over 2, or you can say x equals negative 7.5. Don't forget, we have to check our answer to see if the x we get will make the original argument or arguments positive. So you want to plug in x equals negative 7.5 into the first argument, which is x. Uh-oh, it's making the argument negative. Right? You have log with base 3 of negative 7.5 if you plug it back into the original equation. This is an undefined log. So that means the only possible solution, negative 7.5, is not a solution here. So for this problem, there's no solutions. That will be the end of this video. I hope you find this helpful, and I will see you in the next video. Bye-bye.